Okay, I want to review real quickly what we were talking about last time to kind of get back into the mindset of what we're doing. So in general, we have some kind of expression that looks like this. And yeah, I didn't use a C, I used a D on purpose. So now what we want, well, first off, we said that this thing, it might be in the form of an equation, it might be a function, but it is something that describes something that we care about. Maybe it's a physical system, so we're doing physics, or maybe it's something pure and beautiful just in mathematics itself. And this thing describes something that we care about. And oftentimes, not always, and this is, you'll notice I didn't write an equation on the board. I'm deliberately not thinking about this as an equation. I'm going to stress this so many times that we do not want to think about this thing as an equation. This is right now just an object. We're calling it a polynomial. We're also calling it, this particular one, a quadratic or a parabola. They all mean the same thing. Well, polynomial, quadratic is a special type of polynomial, but it's the idea, right? Now, one of the reasons why we are so interested in this is that this thing usually describes something we care about, and there is some kind of value that we want to find. Like I said before, we have certain situations where maybe this represents the amount of time it takes to get somewhere or whatever, but at any rate, there's some kind of input-output relationship where we want to know how much fuel to give our rocket in order to go a given distance. Or maybe it's the length of rope in order to get a certain area or something like that, right? Mm-hmm. And the idea is, when that's the case, we want to solve for X. And I said before, like, this is what we were saying, is that when you are in this type of situation where you have a quadratic equal to something, it's usually always much easier to say, well, you know what I could do? I could rewrite this. Since D is just a number and Y is just a number, I can rewrite this guy like this. In other words, I could bring the Y over to one side and have a 0, in which case, since D and Y are just numbers, we could consolidate them and say D minus Y is just a number. What number? I don't know. Why don't we just give it a name? Let's call it C. And so you have that type of beast right there. And this is our goal, is to find a general solution to this guy. But in so doing, we don't want to get myopic here. We don't want to think, oh, we're trying to solve an equation. What we want to do is think about, is there another way we could think about this thing, right? This type of thing. Is there another way we could represent it? Can we write it in a different way that might help us do some interesting things? One interesting thing it's going to help us do is solve this type of equation. But there'll be other reasons too. So I just want to be sure what we're getting into is not something one does with an equation. That's very important here. And almost every book I've ever seen that talks about this talks about it as an operation you do on an equation. That's going to screw you up for the rest of your life if you get that in your head. So yes, we care about this equation right now, but there's more in store. So this is the idea, is so the idea was, if we could take this thing right here, this quadratic, and if we could turn it into a different form, and in particular, the form that we're looking for looks something like this. I'm doing A, x minus, that's an h, not a b, that is an x minus h squared, plus Oh, I wanted, that's why I'm doing this. Plus, let's call it M. Okay. If we can rewrite this guy to look like this guy, then, and now if we are talking about this kind of situation where we are trying to find what input value gives you a specific output value, then we could do something like this. We could say, well, these two things are exactly equivalent. X minus h squared plus m. And we could say, since that's the same thing as this, then this equation, this question that we're trying to answer, or this value of x that we're trying to find, can be represented this way instead. And if that's the case, well, we could play the same kind of game and we could find out in general how to do this. We could say, well, take that y over to the other side, and that'll give you a 0. And now you'll have ax minus h squared plus m minus y. And then we notice, well, wait a second, m was just a number, y was just a number. So m minus y is just a number. And we could simplify our lives a little bit by saying, you know, instead of having a total of 1, 2, 3, 4 unknowns, why don't we just rewrite it as, let's give that a new name. Let's call it k. So plus k right there. Now, one thing you'll notice is that last time I didn't have this a out front. I said we're going to be interested in turning these things into this kind of thing, but I didn't have an a there. I was deliberately not going there yet. But this is the case that if these two things are equivalent, it has to be the case that this a right here is the same thing as this a. We'll see that in just a minute. But in general, this is a very general form of what we're doing. So what I want to do right now, we're going to put this on the top. We're going to put something on the top of the board. And it's basically this conversation boiled down into one image. And it's this: given ax squared plus bx plus c. Notice I am not writing an equation because we want to think more generally. In general, what we want is we have an expression like this. And what we want, I'm even going to write want right here. This is what we want, is to turn this type of thing into this type of thing. A x minus h squared plus k. And I said to finally wrap everything up and to get us back to where we were last time, since this is what we want to go in this direction. What we're going to do is study what this direction looks like. In the same way, whereas like if we want to learn how to divide, we ought to study multiplication first, right? That makes sense, right? If we want to be able to factor a polynomial, we better multiply some polynomials first. Otherwise, we're not going to know what we're doing here. Okay, so let's look at this thing right here. So I'm going to erase all of this stuff, but I do want to make one final point. Okay, so that's the big idea right here. This is what we want. And so we are going to go this way a bunch to get a feel for how to go backwards. Now, this is something I want to bring up right now. Let's do this. Before we go any further, let's just make sure, oops, that's supposed to be a square. Let's just make sure that this gives us what we want. The idea was if we could get it into this form, then we could solve any equation. We could solve any equation where that's equal to 0. And let's just look at that real quick. Now, before we do it in general, right? Where we have an actual, before we have, any given A, any given H, any given K, let's just do an example where they are actually given, like a specific case of this type of thing. The one I want to use is this. Now, part 2 of your homework is going to be nothing but this. You will be given stuff that looks like this, and you will be told to solve. And this is how you're going to do it. Now, first off, all right, I'm going to erase this guy. Give me some room here. Now, we did this last time. The only difference was we didn't have a 2 out here, right? We didn't have anything out in front of this. But to get an idea for how to go about doing this, again, what I like to do is look inwards at the innermost thing, which is X, right? Or we always start by looking at X and then work our way out. And we're going to say, okay, what's the first thing that happens to X?
It gets multiplied by 2. No, wait, hold up.
All the way in. We got to look at inside the parentheses first. What happens inside the parentheses?
You subtract 5.
Wait, he gets 5/4 minus off of him. Okay. Now this is where it gets a little tricky, because if we went along with this way, we'd say, okay, then the next thing that happens is he gets squared, right? Yeah. Yeah. That's fine. And so then he gets squared. It's not so tricky. It's tricky in as much as, I don't know about you, but when I look at this, I see, you even said it a second ago, you're like, gets multiplied by 2. Remember the order of operations, right? We got to square this before we multiply it by 2. And let's just be really careful about that. Let's say we had this. 2 times 3 squared. That's the same thing as 2 times 9, because we do that first, which is 18. If we did it the opposite way, let's see what we would have. If we said, okay, here's 2 and here's 3 squared, do the multiplication first. Well, I guess that would be 2 times 3 first. And then is it squared? I guess. So yeah, 6 squared is 36. No, that's not right. That's not what that means, right? This means square that guy first, then do that right there. And so this guy's wrong. We don't do the multiplication first. We got to go working our way out. We got to do the squaring. Then we got to do the multiplying. So, okay, going back. First thing we did was minus 5/4. Then we squared. Then what happens to X?
Then it gets multiplied by 2.
Then it gets multiplied by 2, and the last thing that happens to it is what?
Subtract the 9 or 8.
We subtract 9/8. Okay, and so we put on our socks, we put on our shoes, we put on waterproof boots, then we put on snowshoes. In order to undo all of this, we got to go in the opposite order. So what's the opposite of minus 9/8? Plus 9/8. And then what's the opposite of multiply by 2?
Divide by 2.
Divide by 2. What's the opposite of squaring something?
Square root.
We take a square root. And then the last thing will be, what's the opposite of minus 5/4? Plus 5/4. Okay, so let's go ahead and do that. And again, like when I do these, I usually, if I'm really like don't know what to do, I might write out a little map like this to help me out, like see where to go. But usually the way this works in my head is I just, each time I pretend I'm starting anew. I say, okay, first he gets subtracted, then he gets squared, then he gets multiplied. The last thing that happens is minus 9/8. So the first thing I'm going to do is plus 9/8 on both sides. Okay, that gives me 2x minus 5/4 squared equals positive 9/8. Okay. And yes, okay, yeah, that worked. That was what I said the first step to undo it would be. Now I'm just going to start fresh again and say, okay, x, and he gets minus, then he gets squared. Then finally, the last thing that happens is multiply by 2. So how do I undo multiply by 2?
Divide by 2.
Divide by 2. What does that give me on the right-hand side?
9, oh boy. 9/8 divided by 2 is 9/16.
Yes, 9/16. One way of thinking about anytime you have equations, you could divide both sides by a, right? You could say, I'm going to divide both sides by a like this. And you end up with 1/b equals c/a/d. Or this is a really nice way of thinking about it. Whenever you have denominators and stuff, you could just take one guy from here and move him down there. That's it's effectively the same thing. You could think about just moving them in different ways. So instead of thinking I divide both sides by a, you could think, well, just take what's in the numerator over here and bring them down into the denominator there. I don't know if that helps or not, but basically what my brain saw right here was this. Said, well, this is all a numerator. That has a numerator and denominator. So I could just take this guy and bring him down here, giving me 2 times 8 right there. It's kind of a cheat. I'm kind of skipping a step, if you will, but you can double check that and say, well, what if I multiplied both sides by 2? Oh yeah, if I multiplied by 2, that would kill that guy. Multiply by, oh, I'd be back where I was. Yeah, that is the same thing. Long story short, or short story long, I could also say, well, divide by 2 means multiply by 1/2. And in both cases, right, we end up with the same thing right there. That's so I think it's nice to be able to just see that I could take something from a numerator of one side and drop it down to the denominator of another side. And that's the exact same thing as dividing both sides by that thing. So, is that helpful at all?
Yeah.
Okay, cool. Okay, now, what do? Well, I don't know, let's look at x. What happens to x? Well, he gets minus 5/4 and then he gets squared. So we're going to have to undo the squared thing by doing what?
Square root.
Square root. And what happens when we take a square root in an equation?
You get the plus or minus.
You get the plus or minus. There we go. So this guy drops out. That's why we did it in the first place, was to get rid of that squared. And now we have a plus or minus. What's the square root of 9/16?
3/4.
3/4. There we go. Double check it. Square both sides. If I square that side, I'll get 3/4 times 3/4, which is 9/16. Yep. Square that side, and oh yeah, you end up right where you were. Okay, cool. Nice. Now, finally, what's the last thing I do to get x by itself?
Add 5/4.
There we go. So I add 5/4 to both sides. Okay, what is it? What do we get? Let's do the plus first. That gives us 5/4 plus 3/4 is how many quarters?
2. Well, 8. So
8/4, which reduces to 2. Yeah, you're way ahead of me. Okay.
all right.
Now 5/4 minus 3/4 is what?
1 half. Wait. Yeah, 1 half, right?
Let's see, 5 minus 3 is 2, so we have 2 quarters. So 1 half positive, 1 half.
Yeah.
Positive? Yeah, it's positive. Huh. Now, let's say we wanted to check this. And actually, let's do this a different way. We could have written this as 5 quarters plus 3 quarters, and we could have written it as 5 quarters minus 3 quarters. Okay, so we had an option. We could have kept it like this or kept it like that. I mean, usually this is what we've been doing for like ever now, so that's what you do, right? Well, here's the thing. If we were going to go check this, one of these is really easy to check. Because like, if I plugged in, let's say 2, and I wanted to check this guy, I would have to go, okay, 2 minus 5. Oh, no, 2 minus 5 quarters. I guess that's 8 quarters minus 5 quarters. 8 quarters minus 5 quarters is 3 quarters. Okay. Or if you plugged it in like this, you'd have 5 quarters plus 3 quarters minus 5 quarters. Oh, that would be a lot easier, and you would just get right to 3 quarters. Interesting. I go into this. Yeah, it's Kayla. That's right. Oh, he's been asking for you for a while now. So I go into this in painstaking detail in the homework. Like, it's again a worksheet that I've worked out, and like problem 2 really goes into this like ridiculous detail. This is just something to know, like when you go to check these, if the thing you're checking looks like this, it will be much easier to just leave your answers like this. And I give you an example using square roots and the number I that really makes that point clear. But sometimes if you combine them and get them with a common denominator and reduce, sometimes it makes your checking part that much harder. But at any rate, this is what you're going to be doing in your homework, because these are just skills we want to develop. This is the kind of thing you're going to see. You're going to be given something like this, and in every case, the algorithm's the same, because in every one of these you have x gets plus or minus by something, then it gets squared, then it gets multiplied by something, then it gets added or subtracted by something. And so it's the same order that you're going to want to do it to get back down to x. You're going to get rid of this guy first, then you're going to divide this guy off, then you're going to take a square root, then you're going to undo whatever was the original innermost stuff, either plus or minus, and it's going to look like that. So, okay, now we've worked with one of these before, or now that we have worked with one of these, let's do this first. Okay, so these were the answers we got. X was equal to 2 and equal to 1 half. I'm going to go ahead and erase all this work right here. Now, this isn't strictly necessary, but I do want to do this. I want to see what, since this guy's written like this, let's rewrite it in this form right here. Because this is what we're trying to study right now. We want to notice a couple things. So let's do that. Let's square this guy out. X minus 5 quarters squared is x minus 5 quarters times x minus 5 quarters. Okay. Now, I'm going to do this. That you don't need to do this, but let's not lose sight of what's happening. This is 2 times this entire thing, right? In fact, we could have written that right there at the beginning. It's 2 times whatever you get after you've done this. So this is kind of in parentheses in and of itself. So this is going to be 2 times something I get when I go first, outer, inner, last. And I don't want to miss anything out, right? So this is really important that we keep those parentheses right there. Now, we notice something in the homework, right? Like when you take something, x plus a, say, and you square it, the first always comes out to what?
X squared.
The outer and the inner are always the same. So you have, in this case, x times a plus x times a. In other words, a plus a times x. Or, oh, the same thing. That's 1 plus 1 times ax. Oh, 1 plus 1 is 2. Add something to itself is the same thing. Like, let's just take, let's use a Greek letter. Let's go beta plus beta. Add any number plus itself is the same thing as 2 times that number. And so the outer and the inner are always just going to be 2 times whatever the outer is or whatever the inner is, right? So in this case, we end up with plus 2ax and then finally a squared, right? So what I'm saying is, well, what I'm saying is you do this. What do I get when I first outer inner last this guy?
X squared.
X squared. Now the question is it plus or minus?
Minus.
It's got to be minus because you're minusing 2 things. So now you know it's going to have an x in it, so we don't need to worry about that. 5 quarters plus 5 quarters is the same thing as 5 quarters times 2.
So
So let's see. 5/4 times 2. Does anything cancel there?
yeah, the 4 does. So it's 5/2.
There we go. Now let's just drive this point home. 5/4 plus 5/4 is the same thing as 5 plus 5/4. This is, I'm going to rewrite these. X equals 2 and x equals 1/2. Myself a room. Okay. Oh, hey, look at that. That's the same thing as 5 times 1 plus 1, 4, which is 5 times 2/4. But you also could have said, well, that's 10/4. 5 plus 5 is 10/4, which reduces down to 5/2. A bunch of different ways of looking at it. But in practice, it's so easy to, if you really believe that you're good, that it's that plus itself when you do your outer and your inner, it's so easy to just look at the sign and say it's negative. And then what would happen if I took 5 quarters plus itself is the same thing as just multiply by 2. And so then if there's a fraction, we just reduce that bad boy and say, oh yeah, 5/2. And so this ends up being minus 5/2 x, like that. Okay, and so that was first, outer, inner. What is last?
Plus 25/16, I think.
Here we go, plus 25/16. Now let's distribute that 2 in, and we get 2x squared. Then what?
Minus 5x.
Yep.
Plus 25/8.
Over 8. Okay. And yeah, exactly, right? It's the same kind of thing. Like if I had x plus 25/16 squared, and I was doing my first outer inner last, I'd say, well, of course it's x squared. The outer and the inner is 25/16 and 25/16. Oh, or 25/16 times 2. And so I would say, okay, the plus gives me a plus 25. Instead of over 16, you're going to have a 2. And so it comes out to be 8, right?
Mm-hmm.
Because 2 times that amount is that. anyway. Sorry, that is not at all related to what we're doing right now. That was just an example I just thought of right now. But now, what's 25 eighths minus 9 eighths?
It should just be 16.
I believe so. 25 minus 9 is 16 eighths, which reduces to what?
16. Oh. 2.
2. There we go. So 2x squared minus 5x plus 2 equals 0. You can see this entire thing is exactly equal to 2x squared minus 5x plus 2. And so if that thing is equal to 0, then that thing is equal to 0. And this turns out to be one that we could factor. And without knowing what the answers are, which we do know how it factors, let's suppose that we didn't. Our first is going to have x's in it. And since that 2 is in there, we have to have a 2 in one of them. So let's just do 2x squared. Now, what are my possibilities for here?
1 and 2.
You can try 1 and 2. Let's do 1 and 2. Okay. So my outer gives me what, and my inner gives me what?
You have 4x and 1x.
And 1x. Is there a way of adding or subtracting those guys to give me a minus 5x?
Yeah, they both have to be negative.
They both have to be negative. So I'm going to say 1 and 2, they're both negative. Okay, so this is just starting with this bad boy. We just factored them, straight up factored them. That gives me x equals 2. And what does that one give me?
1/2.
X equals 1/2. Which, lo and behold, it's the same thing we got right here. So we could have, not that this would be more efficient, but if we had started here, went all the way down to, found our x's like we did, we could have just plugged them in and said x minus 2 and x minus 1/2 equals 0. And, oh, that's a little different. We wouldn't have had exactly the same thing. Oh, that's interesting. Now, what's going on here? Something we haven't looked at before. Last time we left this bad boy out every single time. And this is kind of the crux of the matter right here. We'll come right back to this in just a second. You'll notice that if I were to take this bad boy, in fact, I'm going to rewrite it this way. I'm going to say x minus 1/2 and x minus 2 equals 0. Now it's easy to see that the zeros of this are 1/2 and 2. Okay. What are the zeros? How do the zeros change if I take this and multiply it by 2? Now that I've taken this equation and multiplied it by 2, are the zeros any different?
No.
No, they're not. What if I would have multiplied by 700? No, what if I multiplied by 701? Did that change that at all?
No.
No, the zeros are always going to be the same. What we've done here, I'm going to go ahead and just real quick multiply this guy out. First gives me x squared. Outer gives me minus 2x. Inner gives me minus 1/2 x, which is the same thing as minus 4/2 x minus 1/2 x for a total of minus 5/2 x. A positive and a negative make a positive, 2.5 make a 1, and I get a 0. And you can see that if I take this guy and multiply him by 2, we end up with our original thing. We'll get 2x squared minus 5x plus 2. But hey, wait a second. It would have been the same if I had multiplied it by, oh, I don't know, 4. If I took 4, I would have 4x squared minus 4 divided by 2 is 2. So 2 times 5 is 10x plus 4 equals 0 in every one of these cases. What's going on here is, well, we've seen before that when you, like, if I were to give you this, if I gave you this about a month ago and said to factor it, I'll bet that the first thing you do is say, hold up, I could factor out a 2 from each one of these bad boys. And you could, right? You could factor out a 2 and you'd end up with, you'd end up with this guy right here times 2. The point is that the zeros don't determine the original polynomial completely unless we have this term out front. That is, this thing, whatever is in front of the x, right? When you have a completely factored polynomial in terms of just x's, well, then you could take that and multiply it by any number. I could take that and multiply it by 2. And we end up with that original bad boy right there. As a matter of fact, if I just took that and distributed it into the first term, we'd have 2x minus 1, which, oh, hey, that's how we factored this guy. Huh, interesting. Okay. So the point is, we're going to have to deal with if there is a leading term, because all the ones that we dealt, a leading coefficient that's not 1. Last time, every single time, it was 1. But in this case, it changed, right? And we ended up, and indeed, we ended up with a 2 out here as well. That's something we're going to have to deal with. We're going to have to think about that. Any questions about what I just talked about? Okay. So now, yeah, let's just get rid of it. Okay. There's something to notice here. Let's study what we're doing. We're going to take something in this form and put it into this form. So let's just, in general, take the most general one we could find, ax minus h squared plus k. Now let's square this out. What is this squared? The x minus h squared.
X, wait. X squared. Minus 2xh or hx, I guess.
Yep, it doesn't matter, but usually you put the x on the far right, yeah.
Minus h squared or plus.
Plus h squared. It's always going to be a plus. That's going to be really important, actually. It's going to be really important. So what we're hoping for here is, right, we want to be able to turn this thing into this thing, and what we've just done is multiplied it out. Now it looks like we're going to have to distribute the a into every one of these bad boys, and let's just see what happens. Ax squared minus, let's write that as 2ahx. I could have put it in any order. I could have put the a out front, but I usually like to have my numbers out front. And I usually like to have my constants to be in alphabetical order, but it doesn't matter. It really doesn't matter. And so then finally, ah squared plus k. That's what that is. The thing to notice here is if we're gonna find a correspondence between this type of thing and this type of thing, if we could say, now watch what I'm gonna do, I'm gonna use capitals because we don't know what's going on. I'm just gonna say we have a general thing like this. It certainly looks like, if everything's gonna work out, right, that this bit right here, oops, my bad. This bit right here is gonna have to be that bit right there. Because everything else has an X in it, right? Like, if that's the constant term that comes out when you're done, like, we just did this a second ago. I wish we could have left it up to have enough room, but you can go back and check like that this does come out to be that number right there. So those guys are going to have to pair off somehow. The term with just an X in it, or the coefficient of that term, right, with just the X, well, that bit right there is going to have to correspond to that guy right there. And the interesting thing is that that right there has to correspond to that bad boy right there. Because after you multiply everything out, the only thing that has an X squared in it turns out to be this one number right there. And so, like I said earlier, it's not a coincidence that I wrote that with a lowercase a and I wrote that guy with a lowercase a, because it's going to have to be that way. After multiplying this guy out, the only thing that comes along with the X squared is that guy. And so that is going to have to match up with that. They're going to have to be equal. Does that make sense?
Mhm.
That's kind of like what we saw when we did that last example, that if you have a 2x, whatever it was, minus stuff squared plus some other stuff, when you multiply this bad boy out, you get x squared plus some stuff, x plus some stuff, blah, 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 blah. And then you end up with the 2x squared, and then we had a minus 4x, nope, did we have a minus 4x? Minus 5x, minus 5x plus 2. And indeed, that number, we could see where it came from, right? It's just kind of hanging out there. And so then the only place that an x squared comes from is when you square this bad boy out. And so he ends up right there. And then you finally multiply him back in there. That thing is going to have to correspond to that thing right there. Okay, now, so that's the reasoning behind why it's going to have to look like that. Okay. Now, kind of going in a bunch of different directions. Sorry, I'm just erasing all that. You good?
Yeah.
Too late now. Okay. Now, one last thing I want to do before moving on. I said that I don't care what numbers these are, we absolutely can solve this equation. We did it with some ugly, funky stuff a minute ago. And what we could do now is say, well, let's just solve it, right? The innermost thing is this, then it gets squared, then it gets multiplied, then it gets added. So I'm just going to unadd, I'm going to subtract. Okay, there's that. Now, last time K happened to be a negative number. And so when we brought it over, he happened to be positive, right? Like we brought the negative 9/8 over and it became a positive 9/8. So if it happened to be negative, that's fine. We know how to take care of negative numbers in the square root. But in general, this may or may not be negative, right? Because K itself might have been like negative 9/8 like our last time. And so then when we subtracted it off, we got a minus negative 9/8, which turned out to be a positive number. But at any rate, right, without knowing which it is, looks like this. Now what do we do? We're trying to get x by itself. What's the next step?
Divide both sides by a.
Yes, excellent, excellent. And I'm going to go through my reasoning. That's the thing we're getting to. We have to subtract first, then we got to square. The last thing we do is multiply. So we'll get rid of the a by dividing both sides by a. Okay, now what do?
Square root both sides.
Square root both sides. And what happens when we take a square root of both sides?
Plus or minus.
Plus or minus. Okay. Now we don't know if k or a are positive or negative. If, I don't know, in your homework, I told you that a is positive and that k is positive. At this point, you could say, well, since both of those are positive, a positive divided by a positive is positive, but it's negative, so that would be a negative number, in which case I would then have an imaginary number I'd want to pull out. But right now, we don't know whether or not that is the case. I'm not specifying right now. But in this case, it may be positive, it may be negative, whatever, we don't care. If it's negative, we pull out an I. Otherwise, we just leave it alone. It's fine. What's the last thing we want to do?
Plus h from both sides.
We what h?
Add?
Yes. Which gives us two answers, the h plus that thing and the other answer, which is the h minus that thing. If I wanted to, I could go and plug that in and make sure that it works. And oh boy, it does. Let's just look at this and see, does this work? So let's imagine every single value we could plug in. In fact, hold up. There's one thing that a cannot be. What can a never ever be?
0.
Right. But let's look at what happens if a is 0. If a is 0, then your entire expression is just a damned constant, and you wouldn't be doing this in the first place, right? And like if you were given something like this and told, okay, blah, 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 well, a equals 0, then you're not talking about a quadratic at all. You're talking about a line, mx plus b, or bx plus c. But that's just a line. So it's understood that if you do indeed have a quadratic, that a cannot be 0 in either of these cases. Otherwise, you're not talking about a quadratic to begin with. So, okay, a we know is never 0, so we don't have a problem there. If k is positive, you have a negative number. We know how to take square roots of negative numbers. We have no problem there, so that's fine. H could be anything. H could be negative, positive, 0, doesn't matter. Hell, k could be 0 too, because you could take 0 divided by any number, 0, square root of 0 is 0. So what I'm seeing is that this, if, like I said before, if we could turn this guy into this thing, we will be able to solve it for every single number that you put in there, except the one exception is when a is 0. But if a was 0, you wouldn't be doing this in the first place. You would have something like this, and you'd say, well, that means that right there And then that means this right here. And you'd be able to solve for x without any kind of special transferring this over to there. So it's understood that a is not 0. And then in that case, we got no problems. We'll be able to do this for every single a, b, and c that we could possibly imagine. If we could get it to work, which we will. We will. You have to have some faith. Okay. Okay, so I feel confident that this is a good way of solving this bad boy in general. Given ax squared plus bx plus c equals 0, if we could transform this guy to look like this, then we'll have our original problem, looks like this, and we will absolutely, without a doubt, be able to get an answer. So I feel good about that. So let's continue to study real quick. I'm about to send you along your way, but the first part of your homework is basically doing this type of thing. We want to see, sorry. The first part of your homework has stuff like this. So first off, let's do just a couple of these guys. Let's do x plus 3 squared equals what?
X squared
Uh-huh.
plus, oh geez, I'm still really bad at doing it when I don't have it. Like, okay.
What's 3 plus 3?
6x plus 9.
Okay. Okay, what's this one?
X minus x.
I didn't hear you. Sorry.
Oh, I'm sorry, my internet is cutting out.
It's okay.
9. Oh my gosh. Isn't that just 3?
It is just 3. There you go, 3x. The way I did it in my head was I knew that it was 2 times this number.
Mm-hmm.
The same way I know that what this is 2 times that number. I know that 2 times 3 is 6. I know that 2 times 3 halves is 3. And so that's how I did it. You could, if you want, go 3 halves x plus 3 halves x to get 6 halves, which is 3. Much easier to just know that when you're squaring something, you're adding something times itself, or adding something plus itself, which is the same thing as multiplying it by 2. And that's what I'm doing. I look at the sign and go, that sign has to stay the same. And then multiply whatever that guy is by 2, and that's what shows up right there. And then the last is what?
Here. Plus 9. Hold on.
Uh-huh.
9 over 4.
Yes. Yeah, and all I did there, we just said 3 halves squared is 3 halves times 3 halves. Multiply across the top, that gives you a 9. Multiply across the bottom, gives you a 4. There you go. Another way of seeing it is it's just 3 squared over 2 squared. That's cool too. Okay, let's do one more. I'm gonna make a point. Okay, what's this guy?
X squared plus, oh my gosh, 3x plus 9 over 4.
Okay, now, right, because we take whatever that is, multiply it by 2. When I see 3/2 and I multiply by 2, right, we could see, yeah, the 2's cancel, leaves me a 3. Right. And I think in your homework, what I had you do was then say, well, let's actually rewrite each of these. And we could write each one of these as 2 times 3x plus 3 squared. Right. Notice that. Like this right here is plus 2 times negative 3/2 x plus 3/2 squared. This is x squared plus 2 times 3/2 x plus 3/2 squared. Notice I didn't bother writing the minus in here. Like in your homework, I asked for you to do that, right? Where the minus in here matches with the minus in here. But why bother? Like, I know it's going to get squared. The squared is always going to come out as a positive, no matter what, unless you have an imaginary number in here. I will not be giving you imaginary numbers in there. Don't worry about it. But it always comes out to be positive. So I'm not going to waste my time writing a minus in there. But the thing to notice, right, is like, this is kind of interesting. In fact, I'm even gonna rewrite each one of these to make this even simpler. We're gonna say, you know what? This 9/4, I know where it came from. I just took something and squared it. It squared it. It was 3/2. I took something and squared it. Where did it come from? Well, I did first, outer, inner, last. It was the last. It was whatever this is. And I just took it and squared it. Where did that come from? Well, I did first, outer, inner, last. And it was the last thing that I did. And the last thing just ended up getting squared like that. And what you'll notice is that it's kind of like this entire picture is entirely determined by one number, right? And over here, it's entirely determined by this number, the number that shows up over here. But looking at this in the other way, right? Because now we've studied it, we've gone in this direction. How do we go back, right? Because that's what we want, back to our original picture. This is what we want. Given something like this, how do we turn this kind of thing into that kind of thing? Well, what I notice is that one number entirely determines this. And yeah, it shows up here. The problem with this, though, is like I said, it's always going to be positive. It's always going to be positive no matter what. And I could kind of boil this down even more by saying, you know what? This thing that I'm looking for is entirely determined by this right here. Look at that. When it's negative, that's negative. When it's positive, it's positive. And as a matter of fact, more is true. This thing is always 1/2 of that thing. What's 1/2 of 6?
3.
Oh, look at that. What's 1/2 of 3?
3/2.
3/2, right? We don't need to really use our brain at this point. And it's like, well, if you have something like 11, you'd say, well, what's half of 11? 5.5. No. What's 1/2 of 11? 11 divided by 2. 11 over 2. What's 1/2 of 3? 3 divided by 2. What's 1/2 of 6? 6 divided by 2. We could even write it like that if we were so inclined. We could just say that's 6 over 2. If I have x squared, so now let's do this. X squared minus 7x plus something here, and I want to reconstruct what it must have been. This is what your homework looks like. This is exactly what your homework looks like. And I'm asking you to fill in here and fill in here. And so what sign must this be over here?
Minus.
Has to be minus. There's the only way to get a minus is if that's a minus. So that's determined. And what's 1/2 of that?
7/2.
7/2. You don't need to use your brain. It's just whatever symbol you see right there. It's just that symbol over 2. Sometimes it reduces down to 3. If it's 6/2, yes, it does reduce nicely down to 3. When it's even, it reduces that way. And so that's nice. And then you could just say, oh, well, whatever that is, just goes right here. Boom, 7/2. And if you want, you could go and check that, right? First, outer, inner, last. When I do the first, I get an x times an x squared. Outer gives me -7/2. Inner gives me -7/2. -7/2 minus 7/2 is -14/2 or -7. Or I could just say, well, I know how to do this. I just multiply that guy by 2. 7 times 2 is that. Okay, and then I have a 7/2. Nice. Let's do another one that's a little bit more tricky. We're looking for 2 bits of information. We want to know what that sign is and what number that is when we're given something like this. What sign is it?
Plus.
Plus. How do we take half of 3/5?
You multiply it by 2/1, or I guess divide by 2/1 actually. So then you have 3/10.
3/10. Another way of thinking about it is half of something means to multiply the denominator by 2.
Mm-hmm.
It ends up being the same thing, right? Like you said, okay, 3/5 divided by 2 is the same thing as divide by 2/1, which is 3/5 times 1/2. Oh yeah, it's basically, you're just throwing a 2 into the denominator. And so, okay, anyway, let's finish this one up. We have a 3/10 here, so what goes right here?
3/10.
3/10. And if you're so inclined, you could go and multiply all that stuff out and check that, yes, indeed, this does work. This is, now, there's one more before I send you on your way. I keep saying that. Okay, so we have something like this, and we're going to go. Oh, how did I want to do that? Okay. We want to complete this guy right here. Remember what we're doing. You're given something like this, and you want to try to change this thing into that kind of thing. And so we notice that this has to be completely determined. This completely determines that. So what sign does this have to be?
Minus.
Mm-hmm. And we know that we take what of this number? We take a half of it. How do we take a half of a fraction?
Multiply it by 1/2.
Okay, and so what will that look like right here?
3/2n.
There we go. It's that easy. That easy. If it had been a 2, say, if that were 3/2, say what's half of that? Well, half of that is 3/4, because 3/4 plus 3/4 is 6/4 or 3/2. You could also, and indeed, yes, that's what that would have happened. That's what would have happened there, right? Basically, no matter what shows up in there, if you're trying to take half of this thing, just throw a 2 in the denominator. Even if that thing happens to just be a 6, how do you take half of 6? You throw a 2 in the denominator. How do you take half of 7? You throw a 2 in the denominator. How do you take half of A over B? you throw a 2 in the denominator. And in every case, you take that and plus it by itself. A over 2b plus A over 2b equals 2A over 2b, which is just A over b. Oh yeah, that is 1/2 of that thing. So long story short, you want it, this always comes out to be, and you saw this in your homework, that term always comes out to be 2 times whatever that thing is. And so to go now in the direction that we want, given something like that, we say, well, then how do we undo 2 times? Well, you divide by 2. Divide this guy by 2. In other words, put a 2 in the denominator and you end up with the original number. The sign is entirely determined by this sign. And that is how we can start to get from this type of thing into that type of thing. We have not gone too far over today. I'm kind of glad. So your homework is another worksheet. Part 1 is just this stuff. There's 8 of them, 8 or 10 of them. It's not hard at all. Like, again, like we've done even harder stuff than is in the homework. It should not take long. And so that whole problem 1 is your part 1, which is due tomorrow at 8 a.m. The problem 2 is the first type of thing we did with solving equations of this form, where you have ax minus h squared plus k equals 0. The last 2, I tell you that a is bigger than 0 and k is bigger than 0. Just so when you get to the end and you may or may not have a negative in a square root, if these are both positive, then k over a is what?
Positive?
If these are both positive, is this positive?
Yes.
Yes. And so if these are both positive, is that positive?
Yeah. No.
No. Yeah. Okay. So if both k and a are positive, the negative k over a is not positive. And therefore, that can be reduced by doing what?
Taking out the negative.
How do we take out a negative? What comes out?
An I, right?
I. Exactly. And so this is what that means in the last problem. So that's what I'm getting at. If it's just a positive k over a, don't worry about it. If it's a negative k over a, then we're going to simplify.